Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about area under a curve using limits of sums.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. F of x is equal to x squared plus 5 on the interval from 1 to 3, and we have to find the area under the curve using the given interval, using the limit as n goes to infinity of the upper sum. Okay? So first thing I want to note is on our interval from 1 to 3, our function here is increasing, okay? So the upper sum is going to be like a right Riemann sum. We're looking at the right part of the rectangle for the height. Keep that in mind. So let's go set this up as a big limit here. The limit as n approaches infinity of a sum as k, oops, not n, k equals 1 to n. And this is where we want to plug in our function for x. Now remember, this rectangle here, the rectangle we're using for the function here, the height of the rectangle, right, each area of the rectangle is the height times its width. The height is determined by the output of the right of the sum here. So the output is determined by an input that goes into x. So I'm going to leave a space where the x is. Squared plus 5 right here. And this here is going to be the height of the rectangle times we need to find the width of the rectangle, which is at 3 minus 1 over the interval, 3 minus 1 over the number of rectangles we have, which is n. And so you can see it, this is the width of the rectangle. Now we're looking at the right sum, right? The right value of each rectangle, and so we need to start at our first value, 1 for the x. It's going to go in here. So the first left endpoint of all of our function intervals is 1, but we want to find what is the input value of the right rectangle right on the right there. If you see like this curve kind of looks something like this, right? And it's going boop, boop. And we have rectangles here for each one. If you can see, well, that's what's upper sum rectangles actually, like this. If you can see, it's like so small, but we want to find that right value. So if this is 1, we want to find what's the value right there. We add the width to it. So 1 plus whatever our width is, okay? And the width is at 3 minus 1 over n, so that gives us the width of the first one, but we still have to have the variable k here, so we can keep adding it. And now we have a limit that we can, well, solve here, really. So I think I simplify this out first for a little bit. So we have the limit as n approaches infinity, gotta write all this stuff out. K equals 1 to n with a sum here, and we gotta simplify. How far do I simplify in this? Well, that becomes a 2 over k. Oh, I simplified pretty far in here. Okay, so we have a 1 plus, this becomes a 2, so 2 over n k squared plus 5, and then all of that becomes multiplied 2 over, and not much simplification there, but it's our limit as n approaches infinity. We can take our time. N over k equals 1 times, we have to multiply this 1 plus 2 over nk, we have to square that, right, and simplify that, and that comes out to be, I won't bore you with that, that is a 1 plus a 4k over n plus 4k squared over n squared, and we're adding a 5 to that and still multiplying 2 over n, okay? Well, adding the 5 should be pretty easy here. The limit as n approaches infinity of n over, sum of k equals 1 to n of 5 plus the 1 gives me a 6. So it's 6 plus a 4k over n plus 4k squared over n squared, multiplying that by a 2 over n. Alright, distribute that 2 over n to all parts, and what do we get? Well, let's go, yeah, I'm going to do it up here because I'm going to need that space later. We have the limit as n approaches infinity of the summation, k equals 1 to n, multiplied to all parts, and do I have a simplified step, so I just make it easier for myself here. No, I have left it as that. Okay, 2 times 6 is 12, so we have 12 over n, plus, simplify that, multiply out 2n times the 4k over n, is a, ooh, don't lose my spot here, okay, is an 8k, see I wrote my notes wrong for a second, 8k over n, that's what's confused, plus multiply 2 here of an 8k squared over n to the third power, and this is an n squared down here, okay? Alright, so we have this big sum that we need to take here. Let's use our rules, and hopefully I have enough room here. Alright, our rules here to really multiply that out. I'm going to kind of skip a step here, kind of show it all out. But we have the limit here as, I'm putting multiple sums, as n goes to infinity. We're taking a limit of each one, and I'm going to pull out within that step what we have. So I'm going to limit the first part here. I can pull out the 12 over n. So I have a 12 over n times the sum from k equals 1 to n. And what's left is just the value 1. Plus, same thing here, I'm going to pull it out at 8 over n squared. And we're left with the sum from k equals 1 to n of just a k. Plus, here again, same thing, I'm going to pull out at 8 over n cubed. And we're left with just a sum, oof, that's bad sum, k equals 1 over to n of k squared. Just barely. Alright, hopefully you can see that. But basically I'm just separating each one of these out, and I'm left with stuff from our definition here. So again, we're taking the limit of all of that. If you need to see that bracket there it is. The limit here, as n approaches infinity, we have a 12 over n multiplied by 1 just comes out to be an n, plus an 8 over n squared, multiply k, turns out to be that, using our definition, n plus 1 over 2, plus 8 over n to the third power times k squared is that good old n times n plus 1, 2n plus 1. Oof, just barely got it in there. Over 6, don't forget that. Oof, okay. A lot of simplification here, so let's bear with me. N's cancel right there, pretty easy, so we have the limit here as n approaches infinity. We have a 12 going on there, okay? Now, did I cancel that out ahead of time? I think I did. How much did I cancel out? Well, we'll find out. I distribute, the 2 and the 8 goes to the 4, and I actually multiplied this out. This was like a tricky part for me here. Multiplied the n squared and n cancel out, distribute the 4, and so we have now plus a 4n plus 4 over an n right there. Okay, right, so 4, the n squared and n cancel by n here, 4 distributes to both parts, 4n plus 4 over n. Plus, I'm going to do the same thing with the 8 here, okay? So the 8 and 6, what do I have 8 over 3n squared? Oh, that's why. Okay. So to simplify this, I actually multiplied all of this out. Well, I cancel out the n cubed and the n here. So I have the 8 right here. Oh, and multiplied all that out. That's why. Okay. So I multiplied all that out, and I have a 8. So the n plus 2 plus times the 2n plus 1 times the 8 comes out to be an 8n squared plus a 12n plus 4 over a 3n squared. Let me just make sure that 6 got canceled out here, actually. Sorry, that's what it was. 3, just gave me 4. Multiplied all that out. 4 times n plus 1 times 2n plus 1 gave me this 8n squared plus 12n plus 4 over 3n squared. So now we got to keep simplifying here. It gets a little easier because we can't take the limit yet. Okay, and hopefully you're good with simplification. Clearly I make mistakes. It happens sometimes, you get lost in your space, but it's a free video. 4n over n simplifies, and break this up, and I have, well, the n's cancel, I have a 4 plus a 4 over n. Fantastic. 8n squared over 3n squared becomes just an 8 thirds. 3n squared goes in that one here. Over 12n squared, well, we have a 4 in the numerator over just an n. We divide that, simplify, it's an n, plus a 4 over 3n squared. Alright, did I get everything I needed here? 12n over, oh yeah, okay. 12n over, make sure I have the 16 there, 8/3, 4 over n, 4 over n again, or 12n over 3n, or 12 over 3n, which I have, okay, plus a4, okay, great. Either way, now we can take the limit. This here goes to 0 with the n in the denominator, this goes to 0 with n in the denominator, this goes to 0 with n in the denominator, and we're left with a 12 plus 4 plus 8/3, just a constant when we take the limit, and we add all those up, and I did it for you here, 56 over 3, which is equal to an 18.6 repeating. Glad this problem's over. So our final answer, I'm sorry for the little, I don't know, tight work, hopefully you can zoom in, upgraded the camera for that. So our final answer here for the whole upper sum, or n goes infinity of the upper sum, is a 56 over 3. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.